Okay guys, I was talking in class today about the functions that you're pretty familiar with, the cubic and the cubed root function, and I'll just kind of refresh your memory as to what they look like. So this is the cubic function, and the points that we would plot would be 0, 0, and we would plot 1, 1. I'm trying to just kind of show you roughly 1, 1. And then we would also usually plot 2 and 8, so it'd be right about there, okay? So it actually does hit at 2, 8. And the same thing on the left side. So -1, -1, -2, -8. And we know that the cubed root function is pretty much the x and y values are exchanged. And we talked about that in class just a little bit, but I wanted to show you this. So this point right here, we'll just say it's at 8, 2, is actually reflected across a line. Let me show you what line. That line right there. So if I am at 8, 2 here, whoops, there, roughly, I know that I have a point that is over here at 2, 8, and they are reflected across this line. So you kind of see that reflection. So 2, 8 becomes 8, 2, and the same thing on the left side of the equation, or the left side of the graph. So I just want to point that out because you can definitely see that the x and y values change places, exchange. And then they're actually reflected across the line y is equal to x. And that is because they are inverses of each other. So I just wanted to go over that with you. I also want to show you the two graphs we did in class today, x plus 5 and x minus 5. And they're parallel because they have the same slope, obviously. But they are actually also reflected across this line. You can see the symmetry there as well. It's just a little bit harder to see, so I definitely wanted to show you this because it's easier to see that reflection. Okay, I want to do a couple more examples with you, and then you'll be able to do your homework. And so we pretty much filled in this in class today. Let's do a couple more of these. So I think I did 1 and 3 in class, so let's go ahead and do number 2 here. Now, we know that the first thing to do is to exchange x and y. And some of you may not have had time to write all this down today. So exchange x and y. So I think someone asked today in class, where does the negative stay? Well, the negative stays put. So the x and the y literally just change places. Then I'm going to solve for my y. And like I told you, it's almost like you're turning your function inside out. So to solve for y, first I would subtract 8. And then I have a negative y. And then I'm going to divide by -1. So I'm going to divide by -1 here. So I'm going to kind of tidy this up a little bit. So it's going to be a negative 1x plus 8. So it's kind of like this, negative x minus 8. And then I'm going to distribute that, so I get negative x plus 8. So that last part is just your algebraic part of simplifying that down. So the steps are exchange x and y, solve for y, and then the third step is write with your inverse notation. Okay, let's do number 4 here. And you notice all 4 of these examples are lines. We're only dealing with lines today, and then we'll be introducing some more tomorrow. So I'm going to exchange x and y, and I'm going to solve for the y. So the first thing I'm going to do is subtract 10, so I end up with x minus 10 is equal to a negative 2/5 y. And whenever you have something where you have a fraction out front of what you're trying to solve or isolate, it's usually easiest to multiply by the reciprocal. So I'm going to do a -5 halves. It doesn't really matter where you put the negative, but you want to do negative times negative, so it will be a positive y. So these will cancel and these will cancel. Truly, all this is simplifying down to 1y on the right side. So then I must do the same thing on the left side. Be sure to use parentheses, and I multiply by -5 halves. So now I'm going to distribute. So I'm going to -5 halves x, and then I'm going to have plus, because I'm multiplying a negative times a positive, and then I'm going to get a positive 50 over 2. So it's just going to be 25. And then once I'm done solving for y, I write the inverse notation. So that's what we're doing on tonight's homework. So let me just do one from each section for you here. And that doesn't leave you much left to do. So if I want to find the inverse, I know that my values of x and y are simply going to reverse. So I'm going to do this first one with you. So it's going to be -3, 1, 3, -2, 1, 5, and then 4, 6. So that's how you do those. And then down here, these are all pretty much what I just did. Let's go ahead and I'll do number 8 with you. So exchange x and y. And I'm going to go ahead and solve for my y. And you probably notice we're pretty much using reverse PEMDAS to solve, which means I add or subtract first. So I'm going to subtract 5, and then I'm going to multiply by a -3/4 on both sides. So not -3/4, -4/3, sorry. So to clear out the -3/4, okay? So this will simplify down to a 1 on the right side, and then I'll distribute. I get -4/3 x, and then negative times negative is positive, and then I get 20/3, and I'll just leave it like that. And this is your answer, except I need to make sure I put an inverse symbol there. All right, that should give you enough to get going on the homework, and it shouldn't take you more than like 5 more minutes to work through this.